I'd like to thank the IAFF for this opportunity to speak with you today about the Firefighter Cancer Cohort Study. So, as you've already heard, firefighters do have an increased risk of cancer. And as you've already also heard, those cancers are the result of exposures that occurred years ago. That's because of the latency period that Pat was explaining, that's anywhere between 3 and 30 plus years based on the different types of cancers between the exposure and the development of cancer. Therefore, all the studies that you've heard of to date have really been looking at exposures that occurred many years ago. And in addition, the exposures that are occurring now in the workplace are generally going to occur post-retirement in the firefighters as well. What we don't have, with the exception perhaps of some individual cases like the MGUS that David just mentioned, is the understanding about the cellular changes which are intermediate between the exposure and the development of cancer. So understanding those cellular changes is a major focus of the Firefighter Cancer Cohort Study, and I'm going to explain to you in this presentation some of the many advantages of knowing that information. So every study that you've heard about today, except for the World Trade Center study, have been retrospective. So for example, the NIOSH study, you're looking at people when the firefighters when they already have cancer. You're not looking at them before they have cancer. So the Firefighter Cancer Cohort Study is actually going to start with firefighters, new recruits and incumbent firefighters, generally before they have cancer, and then following them forward over time. The advantage of that is it allows you to look, when we combine this with knowledge about the cellular changes, we can look at the effects of current exposures. Those can be things such as new household materials, the plastics that didn't used to be there, the flame retardants which change over time, and also those unique exposures. Not every place is going to have obviously a World Trade Center event, thankfully. But many fire departments have that very large chemical fire. What are the risks of those individual unique exposures? We can also look at that. So knowledge about the cellular changes also allows you to look at the effect of toxic exposures well before the development of cancer. So you can look at them, you don't have to wait 3 to 30 plus years to be able to determine whether a particular exposure is dangerous. In addition, just as David was mentioning with their addition to the 3-city study, we can look at other health effects. For example, reproductive toxicity. We have very little information on that in the fire service. So a prospective study can look at other exposures as well. Most importantly, this will allow us, again, prospective study, looking at the cellular changes to determine the effectiveness of new interventions like contamination control, like diet and exercise, to see whether they're actually reducing the risk of cancer, activation of cancer pathways, these cellular changes. And then where we really want to get to is to identify which of those cellular changes are reversible so that we can treat those firefighters prior to the development of cancer. So my good friend and colleague, Lieutenant Charlie Popp with Boston Fire Department, likes to call the Firefighter Cancer Cohort Study a Framingham study for firefighter cancer. And that really resonates with me because there are a number of similarities. First, the Framingham study is a prospective study just like the Firefighter Cancer Cohort Study. It started many years ago in Framingham, Massachusetts, and at that time we knew very little about what things caused cardiovascular disease and what treatments were effective. So, starting in 1948 through now, we've learned many of the things we know about the associations between cardiovascular disease and diet and exercise, and also the effect of common treatments such as aspirin. We hope with the Firefighter Cancer Cohort Study to make the same type of groundbreaking research and discoveries that will help us to address the firefighter cancer epidemic. So there are some other immediate benefits from this type of study. So as I mentioned, we know very little about the cellular changes that occur, and those cellular mechanisms are critical to improving the cancer claim process for firefighters. So specifically, I was actually present in IARC, and you're going to hear about this later today from Alex Forrest, when IARC reviewed firefighting and cancer. And one of the reasons that they only rated firefighting as possibly carcinogenic to humans was the lack of mechanistic data, lack of information on what those cellular changes were or are. And I believe that with the additional information from the type of cohort studies that have occurred since then and continue to occur, coupled with the mechanistic information, that we should be able to get to at least probably carcinogenic to humans or carcinogenic to humans, and that will help tremendously with both presumptive legislation in general, and I believe with individual cancer claims. So we're currently in the framework stage of the firefighter cancer cohort study. It's supported by FEMA, and we have an incredible partnership among fire service organizations such as the IAFF and others, fire departments, and academic institutions. So roughly, I'll go into each of these pieces in a little bit more detail. It's structured with a fire service oversight and planning board to make sure that we're going down the right direction. We have a data coordinating center where we have uniform information we're collecting from all the fire departments that are participating. We have an exposure assessment center, a biomarker analysis center, and a number of fire service regional partners. So we're going to be taking pre-existing studies in Arizona and in the state of Florida and bringing that on with additional fire departments. Excuse me, we'll be starting with Boston and Indianapolis, and then growing it further. We hope to get it to at least 10,000 firefighters or more to have the type of power that we need to answer the questions. So the Oversight and Planning Board is led by Casey Grant, who I believe a number of you know, who's the executive director of the Fire Protection Research Foundation. And the purpose of the OPB is to provide oversight for the study and to help us also communicate effectively with the fire service and develop a long-term funding plan, because we need this study to go for 30 years or more to get its maximum benefit, although we'll see a number of benefits almost immediately, and I'll share some of those with you. So the Data Coordinating Center is run out of the University of Miami. The lead is Dr. Alberto Caban Martinez, and their aim is to create the harmonized data collection system and data collection protocols. So as soon as we there we go. So as soon as we get IRB approval from the University of Miami, maybe somebody from the University of Miami shut that down right there, but we will be starting with the online consenting process, and this will involve an annual cancer risk survey filled out by the firefighters that allows us, again, to link data between the exposures, the biomarkers, and the health survey information, and this is easily expandable to multiple fire departments. The Exposure Assessment Center is led by Dr. Kenny Fint from NIOSH. You'll hear him later today. And the point of the Exposure Assessment Center is to establish the data collection systems on exposures, which is often the weakness of the retrospective studies, as you've heard. Going prospectively allows us to collect very good exposure information. We have already been partnering with the IAFF to make sure that we have self-reported exposure information as part of the in-force system. That's currently being beta tested. We have a similar system in Florida where we're making sure it's the same questions, and we're going to validate that those questions are important in terms of determining what the individual exposure is to firefighters. We also believe that the in-force system in general, or equivalent such as the PER in Florida, will help firefighters with their claims should they unfortunately develop an illness such as cancer. So I'm the lead of the Biomarker Analysis Center as well as the principal investigator for the overall framework study. But realize again that this is multiple institutions and organizations. So it is truly a team effort. The aim of the Biomarker Analysis Center is to identify those cellular effects. And the way we do that is collecting blood And we often try to get new recruits before they've even had any live fire experience, but we also are looking at incumbent firefighters as well. And then we collect blood every 2 years thereafter. And it's the option of the fire department, should they choose to do this, to also collect baseline and post-exposure urines. And I'll get to that in a moment. So while we can look at a number of cellular changes, the ones we're going to look at initially are epigenetic changes. Epigenetic changes are changes in gene expression without changes in DNA sequence. I like to think of epigenetic changes as the switches that turn on and off gene expression. They are essential in almost all cancers. And the two that we're starting with are gene methylation and microRNA. So, for example, DNA hypermethylation silences tumor suppressor genes, putting you at increased risk of cancer. And microRNAs can either be tumor suppressors, which is good, or oncogenes, which promote cancer, which is bad. So I have just some results to show you today. This is a partial list of our microRNA results. This is based on a previous study that we're working with Tucson Fire to validate these cellular change markers. We compared incumbent firefighters to new recruits. We adjusted for age, which was different, obesity, and ethnicity. And we found 9 microRNAs that were at least 1.5-fold up or down in the incumbent firefighters as compared to the new recruits. And of those, 8 were associated with cancer. And unfortunately, although it's consistent with the reports we have from the epidemiologic studies, in every case where one of the microRNAs was a tumor suppressor, it went down in incumbent firefighters. So that increased their risk of cancer. And in every case where there was a microRNA that was an oncogene, so pro-cancer, it went up in the incumbent firefighters. And if you look at the very bottom line here, that microRNA 48863P, you'll see that it was up over 3-fold in incumbent firefighters. And we know, based on studies in the general population, that that particular microRNA is associated with colorectal cancer, which is up quite a bit in firefighters. So I mentioned, too, that fire departments can choose to collect urine to look at immediate exposures. So, for example, we've been doing work with the Tucson Fire Department using the urine to look at concentrations of polycyclic aromatic hydrocarbons, which contain a number of carcinogens and are always present in a fire. And by looking at concentrations of these chemicals in the urine, we can look at exposures both from inhalation and dermal exposure, and you'll hear a lot more about that later today. But it sums the two together. And I apologize for the very small lettering at the bottom. I realize you guys can't look at that. But just realize that every one of those blue, the dots in the blue, are baseline before the fire, and all the dots in the red are after the fire. And suffice it to say that whichever population we're really looking at in Tucson Fire, there's an increase in these chemicals after the fire. So you would expect, for example, this to occur in the entry teams, the firefighter entry teams, and it does. But what we discovered by doing this analysis is there was an equally large increase in the engineers that were operating the vehicles. So they weren't getting exposures from going in, they were getting exposures likely from the smoke coming off the fire that maybe changed direction after they parked. So based on this information, they put a number of exposure interventions in place. So this is just a partial list, but they're putting all their engineers on air. And because we're partnering with the fire service and we're looking at the questions they care about, they've been able to convince the engineers to do this. There's been very little resistance. It's not the academics going in and telling them, it's the firefighters, based on the data that we have, showing what the risk is. So they're putting these interventions in place. They're also doing washdown before bagging the gear to minimize secondary contamination. And the fire cause investigators, where we have less information but still showing an increase after a fire, they're putting them in air packs and Tyvek suits. So we're currently collecting more urine to see whether these interventions are effective in reducing exposures. So we can look at a number of other things, as I mentioned too, with this study, and we're already putting grant proposals in place to evaluate these. One is to look at the effects of persistent chemical contaminants. One group are these perfluorinated compounds, or PFCs, you may have heard of. They're used in a wide range of products. Unfortunately, they're also in firefighter foams. And this picture here is not snow. This is actually foam that spilled out of, firefighting foam that spilled out of an airport hangar in California. And previously, in another study, a long time ago, we found that two particular PFCs, PFOA and PFNA, when you looked at it in the blood, were associated with decreased lung volume in firefighters. We believe that they have additional toxic effects, but by measuring these in the firefighter cancer cohort study, we can actually look to see whether they activate epigenetic pathways associated with cancer. And so again, we're putting in a proposal to study that. Another area that's extremely important, as you've already heard, is that of cancer screening. So we'll talk just about colorectal cancer. So all cancers are different. But for colorectal cancer specifically, based on the NIOSH study, one you've heard about already, a fantastic study, there was a 31% increase in mortality and a 28% in first cancer incidence in firefighters compared to the general population. So quite an increase. But unfortunately, only about 40% of the firefighters who are supposed to get colorectal cancer screening, colonoscopy, or another technique are getting it. So you have a potentially life-saving intervention that is not being done with the fire service. So just what we would call a low-hanging fruit is to do studies to see if we can increase that screening rate to save firefighters' lives. So that's one thing we're doing, again, with other people, a large group of investigators. Another one is to look at some of those microRNAs, which I already showed to you. Some of those actually predict polyps and cancer in the general population. If they do in firefighters as well, and we're putting in a proposal to study this, then we can identify firefighters at increased risk of colorectal cancer, and then they can get screening early, again, potentially life-saving. So that picture is of a polyp, and essentially, well, I would say all cancers, colorectal cancers, start in those polyps. And the idea is you remove them before they can become cancerous. That's the basic idea. All right, so I'll finish up just with talking about the next steps. So we're in the framework stage. As soon as we get the IRB approval, which should be any day now, we're going to start to enroll fire departments, starting with Boston. They were in our initial proposal. Indianapolis has already decided to join us. We have a number of other fire departments that are interested too. So we will be also converting over the firefighters who've been in our previous studies in Arizona and in Florida to be part of this study. We hope to get, as I said, at least 10,000 firefighters or more. We've had a number of fire departments that are interested in helping us during this interim period before we can get additional funding that will help to support this themselves. So they'll help to collect and process the samples and send them to us. We're also putting together a FEMA study under the direction of the University of Miami to expand this and also look at other populations such as the firefighters that are doing wildland and WUI. And of course, in academia, what we do is we apply for grants all the time, and so we'll continue to do that to make sure that we can get the maximum benefit of this study, again, up to 30 years or more. And with that, I would like to thank all of you for all that you do for us. Thank you.